The graph shows how particle displacement varies with distance for sound wave at one instant in time. The speed of the wave is 340 meters per second. From the graph, determine the amplitude. The amplitude is the maximum displacement, and this is 5 micrometers. Determine the wavelength. So wavelength from here to here is 1.5 wavelength. Okay, this one wavelength, this is half wavelength. So half wavelength, 1.5 wavelength is 2 meters, so the wavelength will be 1.33 meters. Determine the frequency. Frequency is the speed divided by wavelength, so there will be 255 Hz. Determine the phase difference between the vibration of the particle at A and that of the particle at B. The phase angle corresponding to one wavelength is 2 pi radian. So the phase angle corresponding to a distance of d will be d over lambda times 2 pi. Therefore, the phase difference between A and B will be d is 0.5 divided by wavelength 1.33 multiplied by 2 pi. They'll give us 2.36 radians. Which points on the graph correspond to compression and rarefactions on the graph? Indicate them clearly. Rarefactions and compressions occur when the displacement is 0. These are indicated as point P1, P2, P3, and P4. Consider the displacement of the particles next to these points. The particle to the right of P1 is displaced to the right, and the particle to the left of P1 is displaced to the left. Therefore, P1 is rarefaction. Similarly, the particle to the right of P2 moves to the left, and the particle to the left of P2 moves to the right, so P2 is being compressed. Hence, we have P3 is rarefaction and P4 is compression as well. So P1, P3 are rarefactions, P2 and P4 are compressions. Sketch the corresponding pressure versus position graph for the sound wave at this instant. Now, the points of rarefaction are points of minimum pressure, and the points of compression are points of maximum pressure. So the pressure versus position graphs is therefore indicated by the solid line. So displacement antinode is the pressure node, and the displacement node is the pressure antinode.